Automated reed bed installation modules, or ARBI modules, are an innovative new concept to allow efficient and optimized wastewater treatment on site where it may not have been previously possible. They are easily retrofitted to soakaways or existing chemical treatment systems, such as septic tanks. Constructed wetlands, sometimes referred to as reed beds, are an environmentally friendly method of wastewater treatment. They have been used to break down the chemicals added to treat wastewater for decades now, but have had some issues which have prevented their widespread adoption. Most notably is their size. An average constructed wetland of traditional design requires approximately 70 square meters to treat a typical 4-bedroom house. The associated costs of such an installation can be restrictively high. A further problem comes from the need to manage the system, requiring intervention if the system becomes clogged, ultimately leading to the need to refurbish it in its entirety. ARBI addresses these issues by implementing a fully automated industrial control system, which makes measurements of the clog state and water environment and adjusts the module's treatment program accordingly. This not only brings a great increase in treatment efficiency, but also provides a reduced footprint. The modules require no servicing or skilled operators on site, being delivered by a standard skip lorry and then collected the same for return to the distribution centre, where they can be refurbished with no interruption to the end user's treatment. The modules are made up of 3 key elements: the control system, the measurement system, and the water conditioning system. We will look briefly at each one now. At the core of the ARBI modules is a bed of particles, such as gravel, the material of which is selected based on the wastewater to be treated. Plants may also be grown in this to further treat the influent. Wastewater flows through this material where natural microorganisms break down the chemicals present in the water. Particulates are trapped in biofilms secreted by these organisms and in the gaps between the particles. As the water passes through, it becomes treated sufficiently that it can be safely and legally passed into the watercourse. This process is highly dependent on the properties of the wastewater. The levels of dissolved oxygen, the redox potential, the pH, and the temperature can all have adverse or beneficial effects on the treatment efficiency. Optimal treatment occurs in the Goldilocks zone, where all of these parameters are at their ideals. To ensure that the modules run in such condition, the system can make adjustments to maintain equilibrium in these parameters using the water conditioning system. In order to determine what changes need to be made to the system, we need a way to measure the properties of the water. This is achieved using water quality sensors made by Oxygard International, which measure the dissolved oxygen, redox, pH, and temperature of the wastewater. To measure the clogging occurring in the system, we use a magnetic resonance probe. This works using the same principles of medical MRI scanners, but on a smaller basis at greatly reduced cost. These probes measure the amount of water, particulates, and biofilm in the gravel pore space to determine the course of action needed. We will now see the completed system in operation. This module is set up to treat airstrip runoff, which can take place with no other treatment regime. The control system unit, shown here, is responsible for regulating the entire system, from influent delivery through condition monitoring and adjustment to final water quality testing. The influent is fed into the bed through the delivery system here. It passes slowly through the bed, where it is treated by the microorganisms. If we scrape away some of the gravel surface, we can see the wastewater and the bubbles produced by the conditioning system. Closer inspection of the gravel shows the biofilm, which is so important for the treatment of the influent. The structural design of the module is such that they can be easily transported on a skip lorry using these lugs, allowing installation where a traditional wetland would not normally be viable. Multiple modules can be cascaded to reach any level of wastewater treatment. The module which you have seen today is for the treatment of airstrip runoff, but the modules are sufficiently versatile to allow for the treatment of any wastewater. Examples include agricultural wastewater, such as from dairy farming, municipal wastewater after chemical and biological treatments, domestic wastewater after septic tanks in remote locations without main sewerage connection, and industrial wastewater treatment after almost any process where specific treatment media and module liners are used depending on the constituents of the influent. We hope that you've enjoyed learning about the ARBI modules. Further information about the system and the work which has led up to its development is available from our website. Thank you for watching.